Hello guys and welcome to this new video. So today we're gonna talk about maths and it's gonna be a little bit different because we're gonna start like a mini series about linear equations as they told me we're struggling with that. So this is our first video and it's kind of an introduction of what you guys need to know so we can go forward in this topic. So starting by a linear equation, which is basically an equation for a straight line. It's pretty simple. And if we see this graph over here, we see this blue line. And, well, to explain this formula above, which is the formula of this line, we need to look at x and y, which I hope you guys have all that pretty clear. So we can see that as x increases 1, y increases by 2. See? Like 1, 1, 2. So that's why here it's 2x, which is gonna be our slope. And we can see that when x is 0, so this point right here, y is 1, this point right here in red. So that's why up here it's plus 1 because it's positive 1. And if we see these examples, we can see that they work perfectly with this equation to make this line. So if we say x is minus 1, it would be 2 times minus 1. So that's negative 2 plus 1, which is minus 1. And if we see here x minus 1, it is y negative 1. Same with 0, this would be 1, 0, 1. Same with 1, this would be 3, as we can see 1x, y is 3. And same with 2, it would be 5, and we can see x here is 2, and y is here 5. So there are different forms to represent linear equations. The main three forms that we're going to learn today are going to be slope-intercept form, point-slope form, and general form. But all of them must have a constant like m, which is the slope, which in the last slide would be the 2, or c, which in this case is the y-intercept, as we saw in the last slide as well. And they all must have simple variables, which will be x and y. And they can be any letter as long as there's 2. They also must not have variables with exponents or with squares and roots, because that would not be a linear equation anymore. It would come to a more advanced equations. So the first form we're going to see is the slope-intercept form, and it's the most common form of linear equation. It is useful when we know the gradient and the y-intercept of the line. So this is our formula for the slope-intercept form, and we can see m is the gradient or slope and c is the y-intercept. So if we take this graph, for example, we can see that the y-intercept is 2, so here it would go 2. And now we have to find the gradient or slope. Now, we could tell this from the graph, but I want to show you guys another way to tell the gradient, which is with the slope formula, which is this one right here. So for the slope formula, we need to take 2 points in a line, in this case point A and point B. Now, if we look closely, we can see that point A would be 1, 4. It would be 1, 4, as you know, x, y, that's how you do coordinates. And point B would be 3, 8. So we have point A and point B. And, well, we can label this as xy and y1, and this would be x2, y2. And now if we plot this into the formula, we can do first the y, which would be 8 minus 4, which would be 4, and we can do then the x's, which is 3 minus 1, which is 2, And now we put them one on top of each other, 4 divided 2, and that would be 2. So now we can know that the slope or gradient is 2. So the formula for this line here, for example, would be y equals 2x plus 2. Now we see the point slope formula, and this one is useful when we know the gradient and just one point in the line, as we can see here, and the slope here. So this is the point slope formula, and as you guys might notice, it's basically just the gradient formula but rearranged. And well, first to get it, well, that is the coordinates, which in this example would be 4,6, and we got the gradient or slope. And here in this line here, we can see that the point A would be 4,6 and the slope is 0.5. So if we plot this into this formula, we get, well, y1, which is 6, that goes there, and x1, which would be 4, that goes there, and then the gradient, 0.5. So the equation for this line would be y minus 6 equals 0.5 times x minus 4. Finally, the general form, which is not always useful, and honestly it's much better to convert it to slope-intercept form, and well, reuse it because it works better with vertical lines. So here A and B are coefficients and they can both be 0 but not at the same time. For example, if A is 0, B cannot be 0, it needs to be another number. And same the other way around. If B is 0, A needs to be another number. It can be negative, it can be positive, but it cannot be 0. And C can be any number. So if we label this, these 3 are constant, so they are going to be given to us probably, and these 2 are variables. And finally, we have a small list of formulas that we will probably use around the different problems about linear equation, and it would be better if you guys had it like written down in your notebook, as it's important to remember them. So firstly, we have the slope or gradient formula, which is the one we saw before, which is this one. And well, to find this, we need 2 points in the line, and with the 2 points we can do x1 and y1, and then x2 and y2. We subtract them apart from each other, and then we divide them. The second formula we're gonna probably use is distance between 2 points, as you are gonna be given line segments. So a line segment basically is the piece of a line, and it will have a beginning and an end point. So it won't be like an infinite line. So the formula for this, it's a bit longer. It might look scary, but don't worry guys, it's actually pretty easy. We also need, well, the 2 points, the beginning point and the ending point. And so it would be x1, y1, and then x2, y2. We subtract them, square the answer, and then the root of all of this will be the distance between the 2 points. And finally, we have the midpoint of a segment. The formula would be this one. And also pretty easy, the midpoint, well, if it isn't clear, it will be the point in the middle of a line segment, and for this you also need the ending point and the initial point. And well, same here, we have x1, y1, and then x2, y2 for the 2 points, so we add each other, we divide it by 2, and the answer, well, this whole thing will be one coordinate, and this whole thing will be the second coordinate of the midpoint. And well, that's it, guys. I hope you guys enjoyed it, and I hope it was useful. So for the next lesson, we'll probably start solving some actual equations and see how we do there. But I hope it was pretty useful. And please, guys, remember to take notes, because I know it might be kind of annoying, but it's the best way to retain information. So please, please, please remember to take notes about this. Thank you, and we'll see us in another video.